So, the new Ryzen 5000 series has launched already, offering some impressive IPC improvements, and I'm pretty sure all you guys have seen the reviews about it and how amazing it is and how basically Intel is basically irrelevant right now. Except maybe on the low end, how the turntables, right? Anyways, some of you guys might still have Ryzen 3000 series CPUs, and just like me, you might still want to get some extra performance. So I'm here to tell you that if you still have a Ryzen 3000 series, then you can still squeeze out a significant amount of performance out of it, out of some actual overclocking that I could recommend. Now I still have a Ryzen 9 3900X in my main system, which I have experimented on for months to find the ultimate overclocking settings for daily use. Like I've basically changed the settings every weekend, every time I feel like it, since I have the CPU, because I just wanted to find the best settings, and I think I've finally found it. And it involves some clever tricks and techniques that not a lot of people actually use. And here's my Cinebench R20 results as a reference, where you can see that I increased my multi-core by a significant amount compared to stock, and I also kept my single core and in fact increased it by a significant amount as well. So it's not quite catching the new 5000 series CPUs yet, because that's like over 600 points on single core on every CPUs. But this is still a pretty good improvement for Ryzen 3 900X, and for 3000 series CPUs, this is still quite a good score. And this will probably still bring a lot of improvements overall to help application performance across the board. And this is not a simple fixed overclock or just a memory overclock with PBO enabled, but this is instead to a combination of using the EDC bug, which I'll explain later, and also using a BCLK overclock as well as memory overclocking, of course. So that increases the clock speeds across the board, not just setting the all-core clock speed using a fixed overclock but then killing the single core, but you increase the multi-core as well as a single core at the same time. Now my multi-core might not be as high as the guys using a fixed clock speed overclock, but this is still a pretty good score because most of the 3900X I see settled around 4.3 GHz, which gives you like 7800 Cinebench points, which I'm pretty close at, just a bit over 7700 Cinebench points with my setup. Well, I'm still keeping like 540 Cinebench points for single core, so I think that is still quite an impressive score that I got. And so this video will be my ultimate Ryzen 3000 series overclocking guide, with everything you need to know to push it to its limits using a combination of PBO, BCLK overclock, and the EDC bug. And this will probably be the best way to overclock a Ryzen 3000 series for daily use. Now I'm not going to get into advanced memory overclocking because that is quite a dark art that requires at least another whole video to explain it, and in fact I'm not even super knowledgeable on that. I usually just use Ryzen DRAM calculator from One Usmus and tweak some settings here and there. But yeah, I'll just show mostly on the CPU overclocking side in this video. Also, just as a disclaimer, I am not responsible for any damage caused to your hardware from following this guide. Your results may vary and some CPU might take it better or worse than the others, so use this guide at your own risk. And also in my experience from looking at the forums, lots of the guys that experience like degradation and stuff are usually on the earlier Ryzen CPUs, while the guys buying the later Ryzen 3000 CPUs are usually okay with increasing voltages. So keep that in mind. Now before we start, there are some pre-flight checks that you need to do. First off, the hardware. If you want to overclock using BCLK, then you need an X series motherboard that allows a BCLK adjustment. Or I'm not sure if B series motherboards also have these, maybe just some of them, but the boards that I've worked with that are B series usually don't have a BCLK adjustment. Also important to know is that if you want to use the BCLK adjustment for overclocking and you have a SATA drive, then the BCLK adjustment might not be possible and you just won't boot if you try messing with the BCLK. Because that's what happened to me, and I just ended up just unplugging my drive and just using an NVMe drive. But you can still follow this guide for using the EDC bug and how to optimize that if you can't use BCLK. Then you need to make sure you have a sufficiently good cooler because things will get really toasty when overclocked, as you won't be really running the optimal voltages with this type of overclock. But it shouldn't be a big problem as long as you have a good air cooler like a Noctua NHD15 or a water cooler like a Corsair H80i or higher should be sufficient. Now for the software you need to download hardware info, Typhoon Burner, Cinebench R20, Prime 95, and One Usmus Ryzen DRAM calculator. And also some people like to use the Ryzen power plant from One Usmus, but in my experience that the One Usmus power plant seems to boost the CPUs a bit too aggressively, once you're doing these types of overclock and you just encounter some instabilities, at least in my experience. So I just use the default Ryzen balanced power plant, which seems to give basically the same performance, but just better stability overall because it doesn't boost that aggressively. So I recommend you uninstall it if you have the one USMIS Ryzen power plant, or if you don't have it, don't bother installing it. Now for the applications that I mentioned right now, the links are in the description, so feel free to pause the video and download all the required applications. Next, I'm going to define a stability test routine that I use that I'm going to refer to throughout the video. This is basically a simple Cinebench and memory test, which is good enough for 90% of the time, but you should always test for a longer period after you find a pretty stable overclock, and also test your own applications to make sure it's actually stable in your use case, because it might not be stable in some of your programs. The most important part is that you will need to have hardware info open at all times and keep an eye on temperatures to make sure that the CPU temperature does not go to unsafe levels like 90 degrees C or higher, because that's really close to the thermal throttling point, and I think if you overclock this way and you get it that hot, then you might actually see some degradation. So if in any time it gets too hot, you either need a better cooler or you need to back off on the overclock and use a lower voltage and clock speed setting. To test the CPU stability, you need to run Cinebench R20 for a minimum of an hour by increasing the minimum time limit that you can find in the preferences of Cinebench R20. You can just put in an arbitrary number like 99999 and just leave it run until you stop it. It's totally fine. And you have to do this for the multi-core test and also the single core test, and also setting half the thread count in the preference equaling to half of your CPU core. So if you have a 12 core, you put in 6, and if you have an 8 core, you put in 4, for example. The point of these tests is to have a broad range of different loads that trigger different boost frequencies, because you're still keeping the boost algorithm on this type of overclock. After this, you need to open the memtest application that's included in the Ryzen DRAM calculator download. And with the number of CPU cores you have, you should open the same number of instances, because memtest only uses one thread. So if you have a 12 core, you use 12 instances, and if you have a 6 core, you have 6 instances, for example. Not the amount of threads you have, the amount of cores instead. Then you also divide your free memory in your system, which you can check in Task Manager, minus about 2 gigabytes or so, amongst the instances. But if you need to set more than 2048 megabytes on each instances to reach your maximum memory amount, then just open more instances instead, because memtest has a maximum limit of 2 gigabytes each. This is, I think, only on the free version, and the pro version eliminates all this hassle. But the free version basically works the same, it's just a bit of a hassle. Now this needs to be run to at least 100% completion without any errors in memtest or any hardware errors reported in hardware info, which you can find on the end of the pages. When I say check for stability, this is what I meant to tell you to do, all these things, the Cinebench test and also the memtest. And if I say run an overnight stability test, then you need to run each test mentioned overnight, because that's how you really find if it's unstable or not, because sometimes overnight you can find some random errors that just come up in memtest or even in Cinebench. Now that the basics are laid out, we can actually start overclocking. First, go to the BIOS by restarting and hitting Del key repeatedly. You should already know this if you're watching a video on how to overclock. In the BIOS, make sure to load all the default settings and enable the XMP profile. If you have a memory kit that has a rated speed of over 3800 MHz, then adjust the memory speed to below 3800 MHz, because otherwise the Infinity Fabric will just cut in half compared to the memory bandwidth, which is not exactly ideal for performance. Then set the DRAM voltage as well to whatever voltage your memory kit specification is, or maybe about 1.35 volts if you want to be safe with stability. Then save the profile name, default, and save and exit. Now back in Windows, we need to actually make sure that your system is completely stable with all the stock settings before you start overclocking. If you already know your system is completely stable, then that's great, but if not, then you should run the stability test routine that I mentioned earlier, and you should not have any CPU related crashes since it is at default settings. If you have a crash, then it might be memory related, and you might need to increase the memory voltage a bit more or lower the clock speeds a bit more. You can pause this video or come back here later when you're done finding the stable settings at default. Only then you can proceed to overclock. Now go to the BIOS settings and go to the AMD overclocking settings and go to the PBO settings. And if you have a dual CCD Ryzen 9 CPU, set the PPT to 220 watts and the TDC to 200 amps. And if you have a single CCD CPU, set them to 170 watts and 160 amps. The idea is just to set something sufficiently high for now. The next is the EDC, which is where the magic actually happens. Here you need to set the EDC value to 1, and this is the EDC bug that I've been talking about. This will make the CPU disregard the EDC value and just makes it boost all the way to the maximum clock speeds as possible all the time without calculating the EDC required for safety or anything like that. So take it as you will. If you're not comfortable with this, then maybe don't follow this overclocking guide, because this is the whole point of this guide. Then go to the CPU advanced settings and make sure your settings are like mine. The important one is the global C states being off, as that'll interfere with the EDC settings if you leave it as enabled. Now save as a test profile and save and exit. Open hardware info and run a pass of Cinebench, and you should see the all-core speeds have increased by a good amount, as well as the power consumption and temperatures. Make sure that the temperature is not dangerously close to 90 degrees C and that the CPU isn't hitting any limits to 100% except for the EDC, which will probably be like a few thousand%, which is, you can just disregard that. Also take note of the CPU PPT and TDC value. This is very important. Now go back to your PBO settings in the BIOS and put in the PPT and TDC values you see while running Cinebench plus 20 or so on each. This is so a normal heavy workload like Cinebench won't throttle, but something like Prime 95 won't kill your CPU with too much current and temperature. Now go back to Windows and open Prime 95 and try running the small FFT test and make sure that it's actually hitting the TDC and PPT limit that you set, and that your temperatures don't immediately go to 90 degrees on Prime 95. If it still goes to 90 degrees, then maybe lower the PPT and TDC values accordingly so that you limit your CPU so that it doesn't overheat while running Prime 95. This is so that when your CPU runs a program that uses AVX that is as heavy as Prime 95, it won't just immediately crash. And this is one of the advantages compared to a fixed overclock, because on a fixed overclock you can't set a power limit, and because of that, if you run Prime 95 on like a high overclock like 4.4, 4.3 GHz on a Ryzen CPU, then it'll just draw way too much current and just immediately overheat and crash, which is not very good for the CPU. Now when you've dialed in the TDC and PPT values to something that's going to be limiting in Prime 95 but not in other programs, go back to Windows and do the stability test routine and check if it's stable. If it doesn't crash, then congrats, you just enabled Super PBO on your Ryzen CPU. At this point, the system should still be 100% stable since all you're doing is removing the PBO limits. Now, only if your motherboard does not have a BCLK adjustment, then you can try taking it to the next level by setting the PBO scaler to 10x and maximum boost to 200 MHz. But if you have a BCLK adjustment, I suggest leaving those at auto. Again, if your motherboard doesn't have a BCLK adjustment, you can try adjusting the voltage with a negative offset, which will lower the temperatures and power draw and therefore increase clock speeds even more. This is when you need to run a stability test routine for every step lower in the voltage offset that you go. Once you find the lowest voltage limit, then that's all about you can maximize without a BCLK adjustment. The rest of the video is all about the BCLK adjustment, so if you don't have that, then you're pretty much done. If you do have the BCLK adjustment in your motherboard, then go to the BIOS and try increasing it to 101 MHz. Then adjust your memory multiplier and infinity fabric clocks in the AMD overclocking menu so that they are either the same or less than the stock XMP speeds that you verified as stable when you're using the default settings. For now, leave everything else on auto and save and exit. See if your system can boot with this setting. If it successfully boots into Windows, then do the stability test routine, and if it crashes, it will most probably crash in a single core and half core test, which means you need to set the LLC settings in your BIOS to the lowest or least aggressive to lower the multi-core load voltage and add a positive voltage offset to increase the low load voltage. Try with 0.05 volts first and check if it's stable now. If it still isn't stable, then you can add more voltage in steps and check for stability each time until it's stable. Usually with just 101 MHz, you don't really need more than 0.1 volts as a positive voltage offset. And when you're doing this, make sure the multi-core load voltage you see in hardware info isn't getting too high at something like 1.4 volts, as that'll definitely run way too hot. If your system is stable, then you can try going for a higher BCLK and check for stability and add voltage as needed again. Also, when you're adding voltage, make sure that your CPU is not hitting the PPT and TDC limit that you set before, because it'll definitely be drawing more power right now. So if it does hit it in Cinebench and you still have some temperature headroom, you can increase it slightly even more, while still limiting it while running Prime 95. And rinse and repeat until you find the highest stable BCLK that you can run on your CPU. Once you find the highest stable settings, verify it by running the stability test routine but overnight for each test. because this is when you actually find the instabilities and you might need to back off on some of the overclock. Because sometimes if you leave it running for long enough, you might find some instabilities and you might have to back off on the overclock slightly. Now for the finishing touch, open Ryzen DRAM calculator and Typhoon Burner. In Typhoon Burner, click Read, then pick any one of the drop-down options. It should correspond to each one of your memory sticks, and ideally you have all the same memory sticks in your system. Then click Report, scroll to the bottom and click Show Delays in Nanoseconds. Then click Export and click Complete HTML Report. Then save it somewhere you can easily access. Now open Ryzen DRAM calculator, click Import XMP and open the file you saved just now. It should automatically fill most of the options. Just make sure to set the processor to Zen 2 AM4, set the frequency to your memory stick's rated speed, set the BCLK to what you ended up with, and the number of modules the same as how many you have, and the motherboard chipset to what you have as well. Then click the Calculate Save button, and now take a photo of the settings shown and reboot into the BIOS. In the BIOS, go to the Memory Advanced Timing settings and input all the settings from Ryzen DRAM calculator that you took a picture of. Then for the voltage settings, you can disregard everything at this point for now, except for the input DRAM voltage that it recommends, because you're basically still using the stock memory speeds. It should be stable for most setups with the stock auto SoC voltage settings, but if it isn't, then you can try putting in the recommended voltages as well. Back in Windows, run a stability test routine to verify it's stable and run memtest overnight to verify memory stability. Usually an over 1000% pass on the instances without any errors means it's stable. If it crashed, then just set the memory timings back to auto and just use the XMP default settings, because trying to get a memory overclock working with BCLK adds another host of issues that might be not worth it for most people. Although you can experiment with it, obviously. You should end up with a stable super PBO setting, with the EDC bug boosting the clock speeds, as well as an increased BCLK, which will also increase the single core clock speeds accordingly. Most systems will probably end up stable with 102 MHz BCLK, while others might be able to get to 103 MHz or 104 MHz even. In my case, I can only do 102 MHz as 103 will get unstable no matter what I do. Even increasing the SoC voltage to high levels didn't help. Regarding the voltage and temperatures, yes, they will be higher than stock or even on a fixed overclock, but that's just what it takes to get the increased boost levels in both multi and single core. And in my experience with my Ryzen 9 3900X, I haven't really noticed any degradation at all. If you're uncomfortable with it, then just don't do this. But if you want the absolute best performance out of both multi-core and single-core performance on your Ryzen 3000 series CPU, then this is the best way to do it, as it retains the boost behavior and increases it instead. That's all for this guide, and I hope you found it useful and easy to follow. Please do leave comments if you have questions about this, and leave a like if you found it useful. Maybe also subscribe to see more of my future videos. Thanks for watching.